An experiment in calorimetry by comparison. A vessel contains 150 grams of water and a thermometer of the type described in problem 5.9. The whole system is thermally insulated. Initially, the thermometer reading of the system in equilibrium corresponds to a length of 6 centimeters of the mercury column. To this system is added 200 grams of water at an initial temperature corresponding to a thermometer reading of 13 centimeters. After equilibrium has been reached, the thermometer reading is 9.66 centimeters. After this preliminary experiment, a second experiment is performed. A copper block of 500 grams is immersed in the original vessel containing 150 grams of water and the thermometer. The initial thermometer reading is again 6 centimeters. To this system is added 200 grams of water at an initial temperature corresponding to 13 centimeters reading. After equilibrium has been reached, the final reading is 8.92 centimeters. Use the information obtained in the previous problem to answer the following questions. In the preliminary experiment, calculate the heat absorbed by the system consisting of the vessel, the water, and the thermometer. So from the previous problem, we have this specific heat of water in joules per gram centimeter, 15.86. So we can use this information in part A to calculate the heat that is absorbed by the system consisting of the water, the vessel, and the thermometer. So the heat absorbed by the water, vessel, and the thermometer will be minus the heat absorbed by the 200 grams of water. So the 200 grams of water will provide 200 grams times specific heat 15.86 multiplied by delta L. The final L reading is 9.66 in the preliminary experiment. Initial L reading is 13, so it will be equal to 200 times 15.86 times minus 3.34, because Q1 is equal to minus Q prime. Q1 will be equal to this value, calculated value multiplied with minus 1, which is 10,594 joules. So this is the answer to part A. It's the heat absorbed by the water, vessel, and the thermometer. So this is mass of water, specific heat of water, mass of vessel, specific heat of vessel, mass of thermometer, specific heat of thermometer, multiplied with delta L1 is equal to Q1, where delta L1 is now the final reading, 9.66 centimeters minus initial reading 6, which is 3.66 centimeters. So if I call this A times 3.66 will be equal to 10,594 joules. So I will find that my A value is 10,594 divided by 3.66, 2,895 joules per centimeter. Now in part B of the problem, in the temperature range of interest, what is the change of internal energy of 1 gram of water if its temperature changes by an amount corresponding to a 1 centimeter change of thermometer reading? So this is again the specific heat of copper per gram per centimeter in the temperature range. So we're going to have in the second experiment Q2 heat absorbed in the second experiment, mass of water, specific heat of water, mass of vessel, specific heat of vessel, mass of thermometer, specific heat of thermometer, mass of copper, specific heat of copper, multiplied with delta L2 will be equal to minus Q2 prime, where Q2 prime is the heat absorbed by the 200 grams. So this will be equal to, so this part I already know, that's what I called A. So this is 2895 plus 500 grams specific heat of copper multiplied with delta L2. In the second experiment, my final reading is 8.92, so it is 8.92 minus initial reading 6, and this is equal to minus 200 grams 15.86 multiplied with delta L2 prime, which is the final reading 8.92, initial reading 13. So this will give me 2895 plus 500 specific heat of copper multiplied with 2.92 is equal to 215.86 multiplied with 13 minus 8.92, and from this equation I can calculate the specific heat of copper as 3.07 joule per gram centimeter. So for 1 gram of copper, 1 centimeter change in the length will correspond to 3.07 joules change in the internal energy of the copper. So this is just an extension of the previous problem. Now we have 200 grams of copper interacting thermally with a vessel that contains 150 grams of water and thermometer. We know the initial temperature of the 200 grams of water from the temperature reading, thermometer reading of 13 centimeters on that water. So 200 times 15.86 times 9.66 minus 13 is heat absorbed by the water, because 9.66 is the final temperature reading at equilibrium. So it is minus 3.34, which is equal to 10,594 joules for the heat absorbed by the water vessel and the thermometer, because it's minus the heat released by the 200 grams of water. And in this calculation, I have encountered MWCW plus MVCV plus MTCT. That is what I call A. So the change in the length is from 6 centimeters to 9.66, so 3.66 centimeters. So A times 3.66 is 10,594. A is 2,895 joules per centimeter. I use that in part B when I add copper, 500 grams copper times C copper is included in the heat calculation, and I look at the change in the length reading. The final reading is 8.92, initial was 6, and this is minus the heat absorbed by 200 grams of water, which is 215.86, 8.92 minus 13, the initial reading. So from this calculation, I can obtain the specific heat of copper as 3.07 joules per gram centimeter.